Okie doke, so we are going to look at what is a set. So we're looking at set theory, and the first question I suppose to ask is just what is a set? And this I suppose is a key part really of everything that we do for set theory. So a set is a group of objects, a group of things. Okay, the word we use is an element. So it's a group of elements, a group of things put together, which have a clear rule. Okay, and one way of thinking of that is just they need to have a really clear description, to the point that if I gave you this description and you wrote down what you thought was in the set and I wrote down what's in the set, we would agree. We would be agreed on what it was going to be, and anyone we asked would also write down the exact same set. Okay, and the word, I suppose, or the phrase in our definition for a set that I'm kind of referring to there is this idea of it being well defined. So something being well defined means that the definition is very clear, it is clear to everybody what is in that set, and there's no kind of confusion about that. The other word, I suppose, that we have here is distinct. And another word we could think of in that case is just the word unique. So what we're saying here is that the objects within the set have to be different from each other. And I suppose in practice, all that that's going to mean is that we're not going to be repeating things. So if we look at, for example, then an example of a set would be the set of vowels, A, E, I, O, U. None of the letters are repeated, and they're kind of just listed in that usual way. And it is a set because if I say vowels, you would agree or you would know what I'm describing or what the vowels should be. As I've said, then the other word to note is that the items in a set are called the elements. So the elements of the vowel, there's 5 of them, the set of vowels, and the elements are A, E, I, O, and U. Okay. So when we talk about being well defined, as I've kind of talked there, it really just means that it needs to be a clear definition, a clear description of that set. So for example, the odd numbers between 0 and 10, that is a set because it is well defined. If I ask you to write down the odd numbers between 0 and 10, you would write down exactly what anyone else would write down for that. And I suppose the only potential issue there is you not knowing what an odd number is, but that doesn't mean that the definition is poor. Um, by contrast, I suppose a bad definition would be the next one, good movies. So good movies wouldn't be a set because if I asked 20 people to write down the set of good movies, how many are we writing, first of all? Okay, so that's definitely one issue, is how far are we going? And the second bigger issue, I suppose, is what is considered a good movie? So it's not clear to me, like, am I looking at ratings? Am I looking at the money it made? Am I looking at enjoyment? It's too open-ended. There's not a clean definition. And that idea, again, if I asked multiple people to write it down, they would all list different things, probably just movies that they enjoyed, movies that they like. So let's do some practice. So looking at defining some sets. So all we're doing here in this example or in this questions is we need to say whether these are examples of a well-defined set or not, and if not, to explain why not. Okay, so I'm going to do these questions. Obviously, these are the questions that are in your notes, so you might want to stop and pause here if you haven't done the question already, and then if you're confused you can kind of watch on to have them explained. So running through them kind of quickly enough, the pupils in your maths class, that is a set. Okay, that is a set because for the simple reason that if I ask you to list out the pupils in your maths class, you would be able to give me a list, and everyone would give me the same list. Easy school subjects, so this one falls into the same issue as the good movies. So that is not a set, and the reason really is just what is easy. So what I find to be easy might not be what someone else finds to be easy. So therefore we might not agree. We wouldn't probably write down the same things for what are easy school subjects. There's also that idea as well, as we said with the last one, of like how many is that? How many subjects am I considering to be easy? It's not a clean definition, and nor is it a clean kind of number. Vowels, we've already said that is a set. That was one of the examples that were given earlier. And fast animals, that one's going to be a no again. And for the simple reason again, what is fast? Okay, we could probably list some animals, cheetahs, that we think, yeah, they're fast. But then how far do we go? What does somebody consider to be the fast, like still fast? Whereas what does somebody think is just maybe a normal speed? So again, it's not clear enough, the definition is not concrete, and I suppose that's the issue really there. So now that we've kind of defined what a set is, then we want to get into describing the things that are in a set. Okay, and remember that that word is elements. So the things in a set are the elements. So we want ways of maybe describing this and going a little bit further than just a general description. So we have two ways that we can describe a set. So one of the ways we can describe a set is what I've just called the written method. And all I mean by that is we just write a sentence which describes the set. And that's really what we've been seeing in a lot of those examples there. So another example here is that A is the set of natural numbers less than 6. Okay, a natural number is just a counting number. That's your normal numbers. So like 1, 2, 3, 4, 5, 6. Okay, so that's fairly clear. Again, gives a good description of the set. We would all be fairly clear on what's included in the set. The second way that we can describe a set is to just list out the elements of that set, to kind of write out a full list of what is included. Okay, and the example given here is the same example, the numbers less than 6, 1, 2, 3, 4, 5. Okay. So there's, I suppose, 4 different things to consider here when we're listing out the elements of a set. Okay, and I'm going to say there's 5 as well. So one of the things, which I actually haven't even noted here, so let's make a note of it here, the name of a set is typically a capital letter. So generally when we're naming a set, we name it a capital letter. For most of the questions we'll be working with, the set would probably have been named in the question anyway, but just something that's worth noting. So in terms of how we're going to list out the elements of a set, the first thing that you need to be careful of is that we're using curly brackets or chain brackets here. So these are the brackets at either end. This is important for us when we're listing out a set. So anything inside those brackets is considered to be in the set, an element of the set. And anything then obviously that wouldn't be considered to be in the set. We must have curly brackets or chain brackets when we are listing the individual elements of a set. It's really, really important. So if those brackets were missing, that would actually be incorrect. Okay, it would be, there could be potential for confusion there. So when we're listing the elements, we always include brackets. We put a comma between each element, so you can see that in there, there's a comma between them all. That again is important. If I don't have commas, I could run into an issue of, is this 1 and 2, or is it 12, or is it 123? So it's important to have the commas there to separate each of the individual elements. The next thing comes from our definition. We only list each element once. That comes back to the idea we had in the definition of a set, which is that everything is distinct or unique. And the last thing is that order does not matter. So if you have the set 1, 2, 3 and you have the set 3, 2, 1, it's the same group of things, it's the same group of elements, so it is still the same set. And I have just put a note here, which I suppose is important for our own work, is that although order doesn't matter, if we were asked to list the element of a set, we would try maybe and list them in order, if there is an order. So for example, the numbers here, 1, 2, 3, 4, 5, we've listed those in order. It just makes, I suppose, our life easier if we're trying to pick out different elements from the set, but also we're kind of always conscious of, if we're looking at an examiner or if we're looking at a test, of kind of making things that little bit easier where we can. So let's kind of look at an example and do 1 or 2 of the questions here. So we'll go through the example first, and then the questions obviously again are the questions in your booklet, so you might want to give them a go first of all, and then if you need to continue watching, then you can watch that as well. So listing the elements of the following set, the numbers less than 8, well that's simply going to be, make sure that I'm using my curly brackets first, and then 1, 2, 3, 4, 5, sorry, it's less than 8, so we're actually stopping with 7 there. And I make sure I close with my brackets. So I've used my brackets, I've named my set on the outside, I've put my equal sign, I've used my brackets, I've put my comma between all my numbers. Same with the next set A, which is the prime numbers less than 10. So a prime number is a number that can only be divided by itself or 1. The first prime number is actually 2. So 2, 3, 5, 7, and that's all the prime numbers less than 10. And lastly, days of the weekend. For this, we'll go with Saturday and Sunday. Okay, and we write them out in that way. Okay, so listing out our elements, making sure we're using our brackets and our comma between them all. Looking at the other examples here, the first example is the school days. So that would be, for example, Monday, Tuesday, Wednesday, Thursday, Friday. That's our 5 school days. The numbers from 1 to 10, again, straightforward, and we try and keep them in order here. Where there is an order, we're going to kind of stick to that order, making sure that I'm putting my commas between all of them here. C is the prime numbers less than 20, so that's expanding on the one we had in the example earlier. 8 is not 9, is not 10, is not 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, and the letters of mathematics, this is a good example for us. So we're asked for the letters of the word mathematics here. So we'll go through them. We start with M, we go to A, we go to T, we go to H, we go to E. The next letter in the word is M, but we have already included M. And one of the rules we said, okay, is that the things in a set have to be distinct. We don't repeat any letters within our set. So we're not going to add another M. The same reason we're not going to add another A or another T. So we're actually going to jump straight to I, C, and S. So nearly in that way, we get the view of we're literally being asked what letters make up this word. We're not asked how many of each do I need, just what letters do I need to make this word. Okay, so again, that understanding of kind of what a set is generally. So main thing really so far is just, do we understand the definition of a set, that it has to be well defined and distinct, and do we know those rules that we follow when we're listing the elements of a set? Okay, and we're going to continue then into some notation and some work with our diagrams then.